Okay, I need to stay away from swaps and eBay and closeouts and buying. I bought a bunch of stuff recently from I guess a silent key closeout. Somebody else had bought a ton of stuff, and I just bought a smidgen of the ton he had. But this was one of the pieces that was there. It is a high voltage power supply, and looks like for a pair of 3500Zs. I bought it because I saw the high voltage output on it, which is right there if you can see it. 3350 volts DC at 800 milliamp. I'm like, oh boy, that'll make a nice little power supply for a pair of 3500Zs. And I have a few amps that I could use a power supply for a dual 500Z. So I got this for a song and a dance, really, because the seller who had bought this ton of stuff from the closeout from the silent key, you know, this doesn't have any name on it. It looks like it's homemade or custom made. You know, and most people, you know, wouldn't know what it is or what it goes to. So he just wanted to get rid of it. So I got it for a song and a dance, and I opened it up. You know, it's got nice stainless steel sides on it. Very, very well built power supply. But I do think it's homemade, but I think somebody looks like made this off a handbook or something. It's very complicated. And I could reverse engineer it if I have to, but you know, that'd take me a few hours. So I was just wondering if anybody knows what this possibly went to, or you know, what article or ARRL or whatever, where this came from, because this build is overly complicated. And like I say, I could reverse engineer it, but hopefully I won't have to, maybe. So that there's the plate transformer with those markings on it. Looks like 2400 volts at rest and 2200, you know, during load, 800 milliamp, you know, ICAS. And then what really made me think this is for a 3500Z amp is, I know it's upside down, but anyway, that's a Peter Dahl 5 volt center tap at 30 amp filament transformer. And of course, what runs at 5 volts at 30 amps? A pair of 3500Zs. So, you know, you can be pretty much sure that this power supply was built for a pair of 3500Zs. But look how overly complicated it is. First, we'll start out with the little stuff. We got bleeder resistors, these two big green resistors there. It doesn't need equalizing resistors because it's only one oil-filled cap. One cap does not need to be equalizers, but it still needs to be bled, or else that thing would hold a charge for forever. He says 52 UFs, which is a lot. Doesn't say the voltage, but I'm sure that's probably up in, you know, 5 kilovolts or more for that size cap. So very nice cap. Nice transformer. Nice filament transformer. But here's the complicated stuff. You know, this thing has at least 5 relays in there, I counted. Here's a little board that was, you know, stuck on the wall there that came undone. And looks like a little reed relay right there in that little pot. I'm thinking that's a time delay circuit there. And then if you can't, you might could see one, but I'm going to turn it around. That's a contactor there. A vacuum relay right there for the high voltage right before it goes out. Looks like it's disconnected there. I don't know if somebody did that or it unsoldered itself or what, but high voltage relay there. And we got this board here, which is the low voltages, but we'll get to that in a second. Turning her around. There's the high voltage out connection. I've seen that before, but I don't even know what kind of connection that is. I have used them old style, but that's a newer style. I think they're supposed to be safer, but I don't even know the name of that for the high voltage. And then it's got this 12-pin plug here that is marked with, you know, what they do. You know, B minus 5 volt, 28 volt, 115 out. You know, probably all the stuff to the amp it went to run it coming out of that plug there. And turning her around carefully, as it got a little weight to it. It's one of the reasons the guy wanted to just get rid of it. You know, this big old thing with the weight and just sitting there. Here goes another vacuum relay where the coil's connected, but then over here not connected, and me poking around, I don't even know what that went to, or did somebody ultimately bypass it or do what, you know, I don't know. Looked like something was over there, but not anymore. But over here, that looks like a slow start for the or I should soft start, slow start for the high voltage transformer. I did look and see that this is the primary going into the high voltage transformer, and this is also 220 coming in to this board, and then the 220 primary going to the transformer. And that looks like a common slow start board. It looks, you know, looks very similar to what you see on eBay and other places right now. Even though I don't see any markings of who made this board. But that's a slow start for the high voltage transformer. Okay, there's a contactor or relay, so that's two, right? I think those might be high voltage on, but not high voltage, I'm sorry, primary on. That, you know, when you turn a power switch on, you don't want to run full power through to a power supply like this. It would overload the switches. You know, let's go back to the Drake L4B and you know, heat kits. They don't have a circuit or a relay to handle the high power. The switch handles all the power itself. So eventually the switch burns out because you can't, you know, turn on 20 amps or whatever at one time. The switch will fail over time. So use a contactor. So the power switch will turn on the contactor, and the contactor will turn on the amp. And I think that's what those two go. But like I said, I haven't really reverse engineered this thing yet. But vacuum relay, no idea what that goes to. Another vacuum relay for the high voltage, and I showed you that reed relay, you know, over the front, which I don't know what goes to. Use full wave bridge, and those are the block diodes. All that is all the, you know, diodes, maybe 8, 10, depending on the voltage, in one component, you know, sealed in one unit. That's all those block diodes are, right? Makes it a little neater and easier to work with than, you know, having 10 diode strings, you know, and making a string out of it. All those resistors there, my best guess would be the high voltage for the metering, for the high voltage meter. But again, that's just a guess. That resistor there goes to the negative side. That would probably be for the B minus or the current meter or amp meter. That resistor there would probably be the glitch resistor. Works kind of like a fuse, where if it too much amps go through there, that resistor will pop like a fuse and cut off power to it. That's on the high voltage positive. And over here is the low voltage board, and with the low voltage transformer there, third transformer, and you can see it marked maybe 28 volts, 120 volts positive, 110 volts secondary for the time delay. And it looks like 1.25 amps in there. Pretty complicated power supply, right? With all that. So I'm wondering if anybody has an idea of who made this or what it's for, an article or something on it. That would help me out a lot. But I guess if not, you know, we reverse engineered and probably get rid of everything except the stuff for the high voltage and the time delay for the high voltage. And because all the low voltage stuff, at least in the amps I had, are in the amp. So I wouldn't need the low voltage or the filament or anything like that, because that's in the RF deck, at least with my amps. But this one has all that, and we'll probably re-engineer it pretty soon. But this is one of my latest buys, and we got a few more. I got one of my things that was kind of on my bucket list. It's not CB, but some CBers use it. But anyway, it'd be more on that stuff coming later. Bye.